Hello, this video will be looking into a question about boiling point of a solution. Okay, so very straightforward. The first thing the question already asked, boiling point of a solution. Okay, so then you go, how do I calculate this? How do I know? Okay, so remember the title for boiling point was boiling point elevation. Okay, so elevation means what? Again, there's a comparison, right? Elevated from what? So in comparison to the boiling point of the pure solvent by itself. Okay, so if it's an elevation, which means the change in boiling point added to the boiling point of the solvent, then that will be the boiling point of the solution, which is going to be higher than the boiling point of the solvent by itself. So then that fits into the title, which is boiling point elevation, right? Okay, so boiling point elevation. Okay, so now we get this done, then we know, okay, what should we do? Okay, so what should we do is, do we know boiling point of the solvent? Okay, so then normally if the question giving you the solvent as water, so then we probably will now give you the boiling point of water, because that's, as a common sense, we know that's going to be 100 degrees C. Okay, however, if the solvent is a different substance, such as in this case it's benzene, then we'll have to provide you the normal boiling point of benzene, so then you know what that will be, right? Okay, so in this case, the boiling point of the solvent's 80.1 degrees C. Okay, so then the question will be, what's the increase or what's the change for the boiling point? Okay, so then we just need to calculate that. Then we'll be able to do one more step calculation, get to the boiling point of the solution itself. Okay, so how do we calculate delta TB? Okay, so then the equation is I, Van Hoff's factor, times molality times KB. Okay, so then you go, okay, so what's this Van Hoff factor? Okay, so we need to look into the solute itself. Okay, so what's our solute is the C10H8. You go, how do we know that's a solute or not solvent? Then what's the definition? What's considered being a solvent or a solute? Right, so we need to compare which one have more. Okay, so then that's the definition. Okay, then how do we compare? We need to compare the moles. Okay, so then of course in this question, just by looking at 10 gram molar mass, 200 gram and molar mass, right? Okay, so you can quickly, right, just by math, you could see, what do I have more or less? We have more of the benzene in this solution, we have less moles of that C10H8. So then that's our solute, right? Okay, so you know that's our solute. This will have more, so then that's our solvent. Okay, so then that's how you know, right? Okay, so of course you can definitely do the detailed calculation. If you go, I don't have a detailed number, I feel iffy about it. Of course, definitely you can do the calculation. But anyway, so then you can figure this out. Okay, so that's our solute. Then what's our Van Hoff factor for it? Okay, so remember, Van Hoff factor is related to electrolytes. Okay, so you go, I don't know what that is. I have a name, I have a chemical formula. Then you go, how do I know? Right, then we know how to determine a given chemical formula or substance is a strong electrolyte or weak by looking to what kind of compound we have. For this particular compound, C10H8 is all carbon hydrogens. Then we know that's going to be just a molecular compound, so then that's a non-electrolyte. If it's non-electrolyte, which means Van Hoff factor is 1, so which means when you put this into a solvent, it's going to stay as an intact molecule, so it's not going to dissociate into ions, so then I equals to 1. Okay, so now we need to figure out what's the molality. Okay, molality can be calculated as moles of the solute over kilogram of the solvent. Okay, so since we just figured out, so then let's calculate moles of the solute, which is that C10H8. So then we're going to use 10 gram divided by its molar mass, 121.17 gram per mole. We can get most of it. Okay, so that will be 0.078. Okay, I'm going to give it some space. Okay, and then kilogram of solvent, we have 200 grams. That's an easy job. We can use the conversion factor. 1,000 grams equals 1 kilogram. Do this calculation. The denominator will be 0.2. Okay, so now we'll be able to do the calculation. Gives us 0.39 molality. Okay, so now we calculate the molality. Then what's KB? KB is given, right? Okay, so right over here. So then that's 2.53 degrees C per molality. Okay, so now we can just do the calculation. Delta TB equals to 1 times 0.390 multiply 2.53 degrees C per molality. That cancels out. We are calculating degrees C as a temperature change. That's perfect. This comes out as 0.987 degrees C. Go. Are we done? I got the temperature. I'm done. Okay, so think about, we're calculating change, but what do we want? We're actually looking for what's the boiling point of the solution. So we need to add this change to the boiling point for just the solvent by itself. So now it's going to be 80 plus 0.987. This gives us 81.1 degrees C. Okay, so then that's the boiling point of the solution. Remember, it's elevated, it's elevation in comparison to just the pure solvent itself, which is 80.1. It's higher, okay? And then that fits into the concept, and then which means we're on the right track, and then we're done with the calculation. And then hopefully this is helpful, and thank you for listening.